Morning is much better learned after you're well versed in the vocabulary, which you are now that you've gone through Unit 5. Okay, so the first thing you should know, make sure this is down in your notes, that the segment whose endpoints are the midpoints of two sides of the triangle is called a midsegment. Okay, so if you wanted a picture of that, here's my lovely triangle. If I found the midpoint of this side, which would be about right there, and I found the midpoint of this side, which would be about right there, that, what I just threw in right there, is called a midsegment. Okay, now I'm going to be flipping through the slides really quickly, but this is the joy of having a video. Okay, you can pause it right now, take down these notes, and then go ahead and press play again for the next slide. All right, here we go. Okay, so this is the theorem that we're going to prove then. So the triangle midsegment theorem. The midsegment of a triangle is going to be parallel to the third side, and its length is 1/2 the length of the third side. Okay, so if you look at the picture here, MN is going to be my midsegment. Okay, and you can see that it does indeed look like it's going to be parallel to, this is what they call the third side down here, AC. So MN is going to be parallel to AC, and then also the length of MN is going to be half the length of AC. Okay, so that is what we are going to prove. Okay, so pause this slide for a second, take down the triangle midsegment, make sure that's in your notes. Onwards we go, okay? All right, so a couple of problems that apply the triangle midsegment theorem, okay? So you can see from this picture that this is a midsegment because this is obviously a midpoint over here because those two halves are congruent. This is also a midpoint over here because those two halves are congruent, okay? So if this is a midsegment and it's 24 centimeters, that means it's half the length of this side over here. So 24 times 2, that means that A is going to be 48 centimeters. Okay. My computer's done itself. There it is. All right, so now you can see that this is a midsegment here because these two halves are congruent, so that's obviously a midpoint. These two halves are congruent, so this is obviously a midpoint. And then I have my length of my third side. So my third side is 36 centimeters. So my midsegment is going to be half of its length. So 36 divided by 2, D is going to have to be 18 centimeters. Okay? All right, we can also use that idea of those midsegments being parallel to the third side to find some angles, okay? Because if you remember way back last semester when we talked about parallel lines, you had corresponding angles that were congruent. You had alternate interior, all of these kinds of things. Probably what you'll use here most often is corresponding, okay? Because if this midsegment is parallel to this third side, that would make this angle and this angle, these two right here, those are going to be corresponding angles, okay? And corresponding angles are congruent. So if this one's 78, that means I is going to be 78, okay? And same thing here, this 36 and this spot right here are also corresponding angles. So if this is a 36, this one's also 36. All right, now how am I going to find K? Okay, here's where you got to be a little creative, okay? See how actually within this larger triangle there is a smaller triangle up here? All right, any triangle, no matter where it is, always all the angles add up to 180. So if I know this one's 78 and that one's 36, 78 plus 36, yeah, so that's going to be 114. Subtract that from 180. And math for me, but I do believe we're coming out with K being 66 degrees. Pretty cool. All right, let's try another one of those. All right, what about this one? Okay, so same deal here. I still got a midsegment. You can see that these are connecting the midpoints of this side. So that makes this my third side. So I know that these two lines are going to be parallel to each other. Okay, so I'm going to go ahead and start picking out my corresponding angles. So if this one's 82, that would mean this is my corresponding angle. That one's 82. You can see that they're both sitting on top of the lines. Okay. If this one's 76, then that means this one is 76. Okay, so we've got those two going on there. All right, and then let's go ahead and find this one because this is like what we saw in the last one. So got a little triangle going on here. So we'll need to do 76 plus 82. 2 is 8, 15, subtract that from 1. All right, so we're looking at n being 22 degrees. Now there is one more angle they want us to find, which is P, okay? Notice the relationship here between angle M and angle P. They do form a straight line together, okay? Because they're right next to each other, they form that straight line. So that means that if I do 180 minus 82, that will give me 98. So that gives me P being 98 degrees, okay? So make sure, look through these last couple slides, make sure you're good on these kinds of problems. Guarantee you'll see something like it again in the future, all right? But on to what we actually came here to do, okay? So we were definitely wanting to satisfy this target, prove the triangle midsegment theorem, because what good is a theorem if we can't prove it, right? So you should have a worksheet in front of you called the proof of the triangle midsegment. It looks something like this, okay? So let me get my desktop annotate going on here. All right, so now I'm going to be able to work through this with you. Okay, so this kind of takes you step by step. So we're not putting this proof into any kind of a formal form as far as like 2-column or flow chart or anything like that. We're just going to work through it on this worksheet so that you get an idea of how it's done, because they do it via coordinates, which is a kind of proof that we haven't really had too much experience with yet. We'll become very familiar with it by the end of the semester. But this is our first kind of exposure to it. Okay. All right. So you notice you have a picture of the triangle midsegment, just like what you had on the slides. And then part A. So we're going to need to complete the hypothesis and conclusion of the triangle midsegment theorem. And remember, whenever we do this hypothesis and conclusion, what that's basically meaning is what am I given, what am I starting with, and what am I trying to prove, okay? So remember the hypothesis, what we're starting with, the givens, is that we have a midsegment, and midsegments are made of midpoints, okay? So this means that M is the midpoint of this side up here, which would be AB, all right? And then N is the midpoint here of BC, okay? And then what we're trying to prove, we're actually trying to prove two things, right? Because if you look back at your triangle midsegment theorem, it says that the midsegment is parallel to the third side. So my midsegment is in, so we're going to try and prove that it's parallel to AC. And then we're also trying to prove, remember, that the midsegment is half the length of the third side, okay? So it has MN is equal to, well, the third side is going to have to be basically twice its length, right? So, or I'm sorry, take that back, okay? So the midsegment is going to have to be equal to half the length of the third side. Okay. So the next thing, they want us to find the coordinates of the midpoint in terms of A, B, C, H, K, and L. All right, so this is going to be fun. So instead of actually doing the calculation, we're just going to leave all of these letters in for what we would normally use as numbers. Okay, so here we go. So let's go ahead and do midpoint M. Okay, we know that to find a midpoint, we have to add up the x's, divide by 2, add up the y's, divide by 2, and that gives us our midpoint. Okay, so this means that M is going to equal my a's added together, so that would be a plus, or my x's added together, so that would be a plus b, right? Because M is in the middle of these two right here, divided by 2. And then my y's, so h plus k, divided by 2. And for my n is over here. So that's between the x's of b and c. So b plus c divided by 2 over my y's, so k plus l divided by 2. And that's an L, not 1. Okay? All right, take a couple seconds to jot that down real quick. Make sure that you're good on where I got all those numbers from. And then I'm going to have to clear and scroll down here, okay? All right, the next thing they want us to do is to find the slope of AC and MN, okay? So remember, slope, rise over run, okay? Or we could also calculate it by doing y2 minus y1 over x2 minus x1, okay? So since this is up here, I'm going to go ahead and jot down really quickly what the points are for A and C. So A is H, okay. Then we just found M and N up here. Okay, so M, remember, was half of that plus half of that. Then the coordinates of N, and half of this. Okay, all right, so let's go ahead and have our slopes then, okay? So the slope of AC is going to be the difference in y's. So my y's are h and l, so it'll be h minus l over my difference in x's. So that'll be a minus c, okay? And then the slope of an n, now this is going to look kind of nasty, okay, but I promise it'll simplify. So it's going to be your difference in y's. So it's going to be k plus h over 2 minus k plus l over 2 all over, okay, and then the difference in my x's. So I'll have to start with a plus b over 2 minus b plus c over 2. Is that fun? All right, so keep those on the page. Go ahead and flip it over to the back side, okay? So on the back side, okay, pretty simple. It's not going to really simplify much. It was for MN that there's definitely going to be some simplifying, okay? Because you had that one was k plus h over 2 minus k plus l over 2 all over a plus b over 2 minus b plus c over 2. Okay, so let's go ahead and simplify all this down here, okay? First thing you notice, you're subtracting some fractions and they have the same denominator, so that's really nice. We can go ahead and take care of that right away, okay? So basically all I need to do is subtract the tops, okay? So remember when you minus something, that minusing needs to happen to both of these variables. So you're going to have k minus k, which cancels out, right? And then that'll leave you with h minus l on top, divided by 2. Same thing happens down here, okay? So make sure that you minus both of these. So it'll be, well, b minus b is going to cancel out, so that'll just leave us with a minus c all over 2, okay? Remember when you're dividing fractions, don't be shy, flip that divisor and multiply. So it's going to be h minus l over 2 times this flipped, so 2 over a minus c, and nicely enough, that gives me a 2 in the top and a 2 in the bottom. That will cancel out and give me h minus l over a minus c. Okay. Notice something quite nice here. Okay. So you'll see that we have that these two, did I miss it? I did. This should be the other way around, shouldn't it? Y over x's. Shame. There we go. So notice these slopes are the same. And remember that you know that if they are parallel, then they have the same slope. So since AC and MN have the same slope, then they are parallel. Okay. So that is going to be that one, okay? So go ahead and access my next video, and that will give you the answers to part E and F, where we find the length of those sides.